So I will talk about right now solutions for, generally about solutions for the electricity and water industry. And Christoph will talk about a real-life example, what we have realized in Libya. I will try to compare a little bit the two different networks. We are talking about electricity and water. It seems like two different type of animals. But when it comes to networks, they are actually sharing a lot of similarities. I will share a little bit about related terms because I will use a lot of abbreviations and terms later on. Then I will go for the telling a few, the examples about electricity industry, because we believe that electricity metering will be the first step usually, and then in this slide I will continue on with the water industry, and I will talk a little bit about those applications which are shared between the two, at least in our setup. So there are a lot of similarities. The whole network topology of an electrical and the water network is very similar. We have sources, we have a high volume, long distance transportation lines for electricity, high voltages, for water, higher pressures. We have a medium range regional distribution, and we have low power or low volume last mile distribution. Both are wide area networks, as Ferenc, but our specialization is not a local automation, but telemetry on wide area networks. They are all distributed. We have a lot of information sources which have to cover and we have to get information from. Networks need net loss monitoring and also network operation monitoring when it comes to it. And both need industrial size or larger size and household monitoring, being essentially different. However, there are differences, not always between the two, water and electricity, but there are differences how we should realize a network. Well, very simply saying that if we close the tap, water stays in the pipelines. Hopefully, in most of the cases, if we don't have too much problems. But electricity is not stored as it is in its principal format. So it definitely needs different considerations that way. There's a difference in data resolution also, because efficient electricity planning and balancing needs a lot higher information frequency than to work with water systems. Obviously, energy is available every time when we talk about electricity measurements and metering. However, it's not the case for water. So we need definitely an own standalone unit with its own power source. And because of the little bit different natures of the two materials, we need different tools to analyze a network, and also network planning and operations planning is a little bit different for water and electricity networks. Related terms which I will talk about: AMR or AMI, automated meter reading or advanced metering infrastructure. Both of them are very similar. The very first step is automated meter reading. In many of the water metering cases, this is the only step which we can realize. Automated metering infrastructure or advanced metering infrastructure is a little bit different. It already involves two-way communication and ability to influence the household consumption as well. Demand response is a term which we generally use whenever we have an intelligent system, which eventually develops to a smart grid. But demand response means that we can balance our generation or our sources to the demand of the energy, and vice versa. If there is a certain bottleneck in our sourcing, we can limit or we can drive the household customers, or actually industrial customers as well, to lower needs and to balance the network itself. Last mile balance, Ferenc already mentioned this. This is our way of saying that once we can establish a closed distribution system or loop by measuring everything which is consumed at the end or being invoiced at the end, and establishing a baseline what how much energy or how much water we are actually pushing into this loop, then we can create a balance real time and find out the losses by the segments of the network. So, solutions for electricity industry. We have realized EVM system, or actually it's being realized. It's kind of unique for CASON, as we are coming originally more from the fluid type of distributed system, so oil and gas. We are able to realize SCADA systems for system overview and operations of the network. Obviously, remote monitoring and supervision for all of the necessary sites. Let there be anything from power generators to substations in electricity. Remote reading of large customers, or actually limiting their usage or cooperating with them. We can provide a complete wireless communication infrastructure, which is actually meant to realize an AMI system for the household customers. And we provide a so-called SIM application, which is our server platform to take care of the data, the sheer amount of data which is coming in from an AMI system. SCADA and AMI, I'm not really going into details because Christoph will tell a lot more about it, but basically the main thing is that all of the SCADA screens, I mean, actually this is actually a pipeline SCADA, but we are just sharing this type of applications. The SCADA screens really showing what is going on, or representing really what is going on in our network, and able to interface with that. We have trends and also forecasting modules in order to be able to effectively forecast the consumption from our consumers and being able to plan for the generation. We have the metering interfaces, which are able to show either individual or group consumptions from the customers, and also reporting. When it comes to substation monitoring or substation supervision, actually we are just starting to have a project in Syria on that, or at least tendering for this, and we already had very good feedback from the customer wherever we had presentations. We are monitoring basically everything which is on an electrical substation, including the protections, the switch gears, if it's needed, power plant-based or power plant-related information, the cosinus phi, all network and electrical parameters of the system. We are able to implement a so-called first-to-fault, which is quite unique. It means that by using GPS time synchronization, I mean, usually in an electrical network, if something goes wrong, then basically everything goes wrong, because all the systems are going down. Mainly the protections are making sure that nothing is overloaded or damaged in the network. But in order to be able to find the first thing has been faulty, it's necessary to have time synchronization in the network, and this way we can find out which was the original cause which have led to the problem. Also, we can gather in all the information from transformation, including temperatures, oil levels, the power factor of the transformators, whatever is available. It is a modular system. It has different I/Os. We use the same GPRS communication for that, but as Ferenc mentioned, it is also possible to use an Ethernet or fiber optic based communication and use the GPRS as a fallback, or vice versa. In many of the cases, GPRS seems to be much more cost effective than others. And we are providing a multi-vendor solution. It means that in many of the cases we are connecting to ABB or Siemens or Areva equipment. I know that Areva has a very strong footprint in the Middle East, and also Siemens here in the UAE. As far as I know, they are the most preferred vendor for substation equipment. So again, we are not delivering the substations themselves. We are only doing the monitoring, telemetry, controls, and measurements on those. Also, meter reading for large customers, or in fact for substations as well. This is basically establishing the amount of energy which we feed into the feeder lines, the last, for example, 11 kV loops, to be able to create a last mile balance. I can also tell the same properties about this, which we have used. We have special equipments which are, previously, on the previous sides, for example, for substation monitoring, you've seen a modular system because each and every substation has different setup. For only meter reading, we have created a special product, which is on one end RS-485, on the other end GPRS, dedicated for meter reading functions. It can connect to up to 16 meters at the same time, either one phase or single phase or three phase. 31 is the theoretical maximum, because altogether on a Modbus, again very technical, but theoretically 31 is the possible connectable meters, but we usually like to limit it to 16 because of the communication goodness. We already using this in GCOL also, and this is the same solution which we offered in Syria and in many other places. When it comes to household AMI, because so far I've been talking about larger customers or substations, household AMI is a complete solution. You see many elements of this laid out on the table. If you are interested, I'm very happy to discuss with you. But the main thing is this is very flexible, completely radio frequency based on the last mile, because we believe that while GPRS is cost effective for larger customers or substations where a lot of consumption could be invoiced, but in the households where the relative the consumption is relatively low, the cost of a GPRS modem, the power, all of the costs involved, that a monthly subscription of a SIM card and a communication would not be really cost effective. However, we have created a system which is based on radio frequencies to collect all the information from the last mile to the end from the end devices. And while by the time we aggregated enough information, then we are putting it to some other communication barrier, let it be GPRS or Ethernet. We have Ethernet-based coordinators as well. One of our key benefits is that we can connect to most of existing meters. When it comes to electrical meters, any digital meter we can connect to, let it be either a pulse output or if it's needed, then we can connect through serial as well. In water meters, most of the currently equipped water meters can be fitted with a pulse output device, or they already have a pulse output, which is enabling us to use even normal standard counter water meters, or the digital water meters if they are equipped, and obviously we can even close valves or do any other possibilities as well. So the system, we are able to provide it on two frequencies, depending on the local legislations and the radio frequency situation. Either 2.4 gigahertz. It is basically the same free frequency band as Wi-Fi or Bluetooth is using everywhere in the world. But the technology is created such a way that they are not interfering with each other. Or we are currently developing, or actually already testing, lower frequency equipments which are able to penetrate more walls and able to cover larger areas and with the same possibilities. Also, we are doing time synchronization in this network, which is essential when we want to establish a last mile balance, in order to be able to measure everything at the same time in the network and be able to compare the consumptions.